Hey guys, so today we have notes on factoring with our box method. It's an inverse box method, and it's a really cool way to factor quadratic functions whenever we start getting into quadratic functions that have an a value greater than 1. So I have labeled today's notes factoring with box method inverse, and the attached document that's on your Google assignment today, it's going to get glued into this page and just folded in half like a book, so that the single printed part that only looks like it takes up half a page will actually be your cover, and then the page that has something on both sides will be on the inside. So our examples are on the inside. So I want to start by reminding you, as we get into quadratics, you guys have looked at quadratics in Math 1 and you have factored in Math 1, so we're going to go back into that. And if you remember, factoring at all, you either FOILed or you used the box method, which is where polynomials were given to you and they were in their own parentheses, and you would use that box method to figure out, well, what happens when I multiply the first terms and then the outside terms and the inside terms, and you would kind of organize everything in a box and take what was inside the box, and that would be your answer. Well, what we're going to do is figure out how to do that backwards. So we're going to factor using the inverse box method. So to refresh your memory again, the standard form for a quadratic equation is ax squared plus bx plus c. So again, as long as your x is squared, it's going to be a quadratic function. And you can also have just plain x squared. That's still a quadratic function. You can have just the ax squared and the bx, or you can have all three parts. So really the only thing that's needed is that x squared in order for you to know that it is quadratic. But to factor it out, when it's got all three of these parts, we start to think to ourselves, I've got to open this up and figure out what numbers are going to multiply and add together to give me this in the simplest form. So we're basically working backwards to get it in its non-simplified form, if this would be the simplified form. And so we're going to do the box method backwards. So A will be this first top square. B, the bx, anything that's going to add up to give us bx, is these two squares right here. And then C is this bottom square. So I know that you guys in the past, if you've had, x plus 1 times x plus 1, you would put those values here and multiply them together to get your answers, and then this would be your standard form. But we're going to do it backwards. They're going to give us the standard form, and you're going to tell me what these numbers would be. So these still go in the same places as before. Our ax squared will go here. These two numbers should add up to give us bx, and then c is going to go down here. So to figure out what goes in these two boxes, again, because we can put the ax here and the c here, but we have to split the bx, to split it up. To figure out what goes in those boxes, you're going to say, I need to think of a number that's going to multiply to give me a times c, but also add up to give me what this b value is. And so that's where it kind of gets fun. You start thinking, what can multiply to give me this and add to give me that? And your factoring chart sheet is going to be super handy for this. So if you needed to think of a number that, multiplied to give you 8 but added up to give you 9, you would go to your 8 chart and say, okay, well, 1 times 8 gives me 8 when I multiply, but 1 plus 8 gives me 9 when I'm adding. So those could be my two numbers. So you can use this to kind of help you if you're getting stuck, at all. So to figure that out, you're going to write this down. Now, what number multiplies to give me a and c, and what number adds up to give me that b in the middle. Then, once you've got those numbers, you're going to plug them into your boxes. So your ax squared will go here, your c will go here, and you're going to fill in those two values that will add up to give you bx right here. To figure out what these outside numbers are, because again, we're working inside out this time, you take the greatest common factor of each column. So the greatest number that can come out of both of those, the greatest factor, and then the greatest variable that you can pull out. So the biggest number that can factor into both and the most letters. And then same for these rows. 1 and 2 go here, the greatest common factor, and 3 and 4, the greatest common factor goes here. So you take what you have on the inside and you pull out the greatest common factors, and then that way you'll have the factored form from the standard form. So your factored form would be this greatest common factor here plus this one here. So if they're on the same side, they go in the same parentheses. These two go into parentheses together, and then these two on the top go into parentheses together. The greatest common factor of 1 and 3 and 2 and 4. So these columns go together and these rows go together. And I know that seems like a lot and this might be confusing, but that's why there's 4 examples on today's notes that I want to do with you guys. So that'll make it a lot easier to understand. So let's look at example number 1. X squared plus 8x plus 16. So I want you to tell me what the factored form of this quadratic equation would be. So looking at this, we need to figure out, okay, well, what are my values? How do I figure out what multiplies and adds to give me this? And then we can go into our box. So from your equation, you need to write out A, B, and C. So you can look at that and see. Well, A is always in front of the x squared. And if you don't see anything, we know that that's an imaginary 1. When we're multiplying or dividing, we never put the 1 because 1 times anything won't change the value. And then anything divided by 1 also won't change the value. So we never really write those because it doesn't do anything. So if you don't see anything, you know that your A value is 1. Well, this is my B value, which is 8. And this is my C value, which is 16. So just looking, I can see what my numbers are. Well, now I need to think to myself, okay, I need to think of a number that's going to multiply with another number to give me A times C, which is 1 times 16, which is just 16. But also it's going to add up to give me 8. What could that be? And you can go to your factored forms if you want. It's got to add up to give you 8 and multiply to give you 16. So let's go to 16 and look at the factors that we have. So for 16, 1 times 16 equals 16, 2 times 8 equals 16, and 4 times 4 equals 16. Which one of these sets is going to add up to give me 8? 1 and 16, 2 and 8, or 4 and 4? I'm thinking 4 and 4. 4 plus 4, if I make them both positive, can give me 8. So the number that I'm going to use is 4. 4 times 4 will give me 16, and 4 plus 4 will give me 8. So those are going to be the two numbers that I need for these boxes to split up this 8x. So when I come down here, I just go ahead and write what my A is and what my C is. Those are given. The hard part was having to split up this middle value and figure out what two numbers can multiply and add to give me those. And we've done that. We've done the hard part. So now we put those in box 2 and 3. These two numbers go here. Now remember, it has to add up to give us this middle term. So I've got to put the x's back with it, right? So this would actually be 4x and another 4x. So at this point, this equation, if I were to open it up a little bit, is now this. I've got to pull out my GCF from each column and each row. So in this first column, what is the largest number I can pull out? And remember, your largest factor can never be bigger than your smallest term. So if there's an imaginary 1 right here, what's the biggest number that can go into 1 and 4? 1. It cannot be bigger than my smallest number. So the 1 is the only thing I can pull out. And then let's look at the letters. I have to pull out the same amount of letters from both terms. Can I at least pull 1x out of both of these? Well, yes. This one has 2 x's. This one only has 1. So I can at least pull 1x out of both. Can I pull 2 x's from both? No, I cannot. This one does have 2. This has x times x. This one only has 1x. So remember, I can never pull more than the smallest amount that I have. So the greatest common factor in both of those is just x. And you can put 1x if you want, but I don't write the 1. Let's look at this column. What's the largest number that I can pull from 4 and 16? Well, it cannot be bigger than my smallest number. So 1 can go into both of these. 2 can go into both of these. 3 cannot. 4 can go into both of these. So 4 would be my greatest common factor, right? 4 can go into 4 one time, and 4 can go into 16 4 times. Now, letter-wise, this one has an X, this one does not. So is there any letters that I can pull from both? It has to be a common factor that's in both of them. There's not. They don't both have an X, so I cannot pull an X from both of them. So just 4 is the greatest common factor that I have. Now let's look at our rows here. Let's look at this first row. What's the greatest factor between 1 and 4? Or the biggest number that can go into both of those? Well, 1 can go into 1 and 1 can go into 4, and I can't go over my smallest number. So 1. I'm not going to write the 1 because we don't ever write them. And then let's look at our letters. This one has 2 X's and this one only has 1. What's the biggest number of X's that I can pull from both of them? So this one I can pull 2 X's out of. This one I only have 1 to pull out of. So remember, I can never pull more than the smallest amount that I have. Since this one only has 1, I can only pull 1 from both of them. And then if we look at this row, what's the biggest number I can pull from both of these? Well, 1 can go into both of those. 2 can go into both of those. 3 cannot. 4 can go into both of those, and I can't go over 4 because that's my smallest number. 4 can go into 4 one time. 4 can go into 16 4 times. So that is a common factor, so I can put that here. Now letters, is there a common letter that I can pull from both of them? There's not. 16 doesn't have a letter, so there's not a common letter and even a common amount of letters I can pull from both. So that's it. That's all I have. So now to write this equation in factored form, I'm just going to put these in a parentheses together, x and a positive 4, and these in a parentheses together, x and a positive 4. Standard, factored. And if you want, you can always check your work. So if I were to go back and factor this out, this times this is x squared. This times this is positive 4x. This times this is positive 4x. And this times this is positive 16. These are like terms, so they combine to give me x squared plus 8x plus 16. And what do you know? This is exactly what we started with. So it's right. The math makes sense and it works. Let's look at example 2. X squared minus 5x minus 14. So my a value is 1. My b value is negative 5. Remember, those symbols that are in front of your numbers, they go with your numbers. They're not just hanging out in space. And negative 14 for my c value. So I need to think of a number that can multiply to give me negative 14, right? My a and c values multiplied together. And I need to think of a number that's going to add up to give me negative 5. So it needs to multiply to give me negative 14. Let's go to our factor sheet and let's look at 14. The factors of 14 are 1 times 14 and 2 times 7. These are the only 2 sets of numbers that will multiply to give me 14. Now, which ones can I make add up to give me 5? These 2. I can do a positive 7 and a negative 2, right? 7 minus 2, if I add those together, that will give me 5. So right here, we're going to say, oh, this actually needs to be a negative 5, excuse me. We're going to say negative 7 and a positive 2, because negative 7 plus 2 brings me to negative 5. But negative 7 times 2 gives me negative 14. So that works. So now we're going to come down here. We're just going to write in our a value and our c value, because those are constants. What we were trying to do was figure out how to split this b value. So now we have negative 7 and 2. So negative 7x and a positive 2x will add up to give me negative 5x. So this is the b value split. 2 and 3 add up to give us that middle part, right? So now we just have to pull out our GCFs. What's the greatest number that can go into both 1 and negative 7? 1, right? You can't ever go bigger than your smallest number. And how many x's, what's the common number of x's that they both have? Well, they both have at least 1, and I can't go bigger than that. Well, let's look at this column. What's the greatest common factor that can go into 2 and 14? 2, right? 2 can go into 2 one time, and 2 can go into 14 7 times. And I can't do a number bigger than 2 because I can never go bigger than my smallest number. So 2. And then is there a common number of x's that they both have? No, only this one has an x. So there's no variables that I can pull out. But if we look at the column or the rows now, what's the common number that can be pulled out of 1 and 2? Remember, there's an imaginary 1 right here. 1. You can't ever go bigger than your smallest number. And what's the common number of x's that I can pull out? Well, they both have at least one x. There's one x here and there's two x's here. So the common number of x's I can pull out from both is 1x. And then is there a common factor between -7 and -14? Yes, there is. -7 can go into both of those, right? -7 can go into -7 once, and -7 can go into -14 twice. And is there a common number of x's? There is not. So these would be my factors. These are going to go together, x and a -7, and these are going to go together, x and a +2. And again, please feel free to check your work. I apologize for that. The lights in here are timed. So let's factor it backwards, back to our original. You don't have to do this step. I'm just doing this to show you that these truthfully do take you back to your original, and it is right. X times x is x squared. X times 2x is +2x. -7 times x is -7x. And -7 times +2 is -14. Well, these are like terms, so we'll combine those. And what do you know? It is the same. So this is the factored form of this standard form. So if I gave you this factored form, you could use the box method by putting these on the outside and multiplying them together to get your standard. But we're doing it backwards. We're filling in the inside and pulling out those GCFs, which is going to be really, really handy when our A value is no longer 1. Right now it's really simple because our A value is 1. But sometimes it's not always 1. Sometimes it's greater than 1. So let's look at 3 and 4. I think one of them is an A value larger than 1. Here we go. This is going to be a little hard to write on because I've already got it glued into my notebook. Let me try to open this up. Okay, so example number 3, we have x squared minus 3x plus 2. So our A value is 1, our B value is -3, and our C value is 2. So it has to add up to give me that A and C multiplied together, which is 1 times 2, or 2. It has to add up to give us -3. So the only thing I'm thinking is 1 times 2, right? 1 times 2 is going to multiply to give me 2, but I can make it add up to give me -3. Now, if I want this to be -3, both of these are going to have to be negative. -1 plus -2 is -3. And we know when you multiply two negatives, it actually becomes a positive. So we're going to come down here to our box. We're going to fill in our A value and fill in our C value. Remember, this is A and this is C. B is the one that's going to get split. It's going to get split into these two boxes. And we're going to put these two numbers that we just figured out, -1 and -2. Keep those x's with it because it has to add up to give us -3x. And now we pull out our GCFs. So again, the greatest number here is 1. And the greatest number of x's that they both have is just 1x. In this column, the greatest number is 2. And they both don't have an x. So all I can pull out is that -2. And then in this column, my greatest number, it just seems to be 1. We can't pull out anything bigger than our lowest number. And then the greatest number of x's is just 1x. And then down here, the greatest number I can pull out is 1. And there's not the same number of x's in both of them. So I'm just going to pull out this -1. And so if there's that negative symbol with that x, go ahead and pull that out. We don't want to forget about those. So now this would be my factored form. We're going to put x minus 1 in one set of parentheses and x minus 2 in the other set of parentheses. And that is the factored form of this standard equation. This last one has an a value that is greater than 1, as you can see right here. Our a value is actually 2. So our a value is 2, our b value is 9, and our c value is 10. So we need to think of a number that's going to multiply to give us that times that, which is 20, but add up to give us 9. Fun times. So again, you can go back to your factored sheet and look and see which one. In my head, when I'm thinking of numbers that give me 20, I always start with my multiplication. And I say, okay, what numbers can multiply to give me this? And then I think of a way to make them add up to give me 20. I have 1 times 20, and there's no way I can make those add or subtract or anything to give me 9. I have 2 times 10, and I could do 10 minus 2, but that would give me 8. There's nothing for 3, and then for 4, I have 4 times 5. Well, I make 4 and 5 add up to 9. So I'm going to say it's 4 and it's 5, right? Because those multiply to give me 20, but add to give me 9. So let's go ahead and bring down our a value and our c value. And then let's put those numbers that we just came up with in these boxes. And remember, put them with your x values because it has to add up to give you 9x. And now we're going to pull out our GCFs. Well, what's the greatest number that can go into both 2 and 5? And it can't be bigger than 2. Well, 1 can go into both of them. 2 can go into 2, but 2 can't go into 5 evenly, right? There'll be some leftover. So 1 is the only number. And how many x's do they both have? This one has 2. See how it's x squared? This one only has 1. So how many can I pull from both? The same amount from both of them. I can only pull 1 out. I can't pull 2 from both because they both don't have 2. Let's look at this column. What number can go into both 4 and 10? The greatest number. Well, 1 can go into 4 and 10. 2 can go into 4 and 10. 3 cannot. 4 can go into 4, but 4 can't go into 10 without having a little bit left over, right? It's 4, 8, 12. So it's never going to sit evenly right on that 10. So 2 is the biggest number that can go into both of those with no leftovers. 2 can go into 4 2 times, and 2 can go into 10 5 times. So 2 is my greatest factor, and they both don't have an x, so I can't pull an x from both of them. Now let's look at this row. The greatest common factor between 2 and 4 is 2, and the greatest common number of x's that I can pull from both of them is just 1. The greatest common factor in 5 and 10 is 5, and they both don't have a letter, so I can't pull an x from both of them. So these are going to go in my parentheses. So we have 2x and a positive 5, and an x and a positive 2. So in this case, when your a value is not 1 and you put it here, this is going to make it easier to find that factored form. And we're going to get more into that later on this week. But those are going to be a little bit more difficult, but using this inverse box method is going to be super helpful in doing that for you. That is it for your notes today. I know that was a little bit longer than 20 minutes, and I apologize. But tomorrow and the next day, you're going to work on factoring quadratic equations that are given to you where your a value might be 1 or it might not be 1. So these notes are going to be super handy for the next few days. That's all I have for you today, and I will see you guys later.